If you have power supplies that support USB-C PD or quick charge, you can use these for powering your own electronics projects or other products that require voltages other than 5 volts. USB-C PD and quick charge protocols allow voltages other than 5 volts like 9, 12, 15 and 20 volts, and you can get those voltages to come out of power supplies by using a PD trigger or QC trigger board. This is a QC trigger. It will allow you to configure the output voltage of a power supply. Let's have a look at that. If we use a USB measuring device, we can see the voltage. So that's 5 volts, 9 volts, 12 volts. Not many QC devices support 20 volts. Now this one does. It also supports QC3 mode, which allows you to change the voltage in increments of about 200 millivolts, all the way up to 20 volts or 15 volts, depending on what the power supply supports. Similarly, for USB-C PD, this is a USB-C PD trigger board, and that allows you to configure the output voltage of the power supply to different voltages. They sometimes don't like you cycling the voltage very fast, and it will cause the power supply to restart. So all the way up to 20 volts, and the color of the LED there indicates what voltage it's currently outputting. These things are fine for testing the capabilities of a power supply, but they're not very good for building into your projects. So for that case, you can get boards where you either configure the voltage by dip switches. This one's a QC trigger, but with a USB-C connector, which is a bit strange. But if your PD port also supports QC, then there you go, that one's configured to 12 volts currently. Or you can get this type, which you buy already configured for the voltage you want to use it with. This one is also 12 volts. Or there's these tiny little ones for USB-C PD, which can either be configured using solder blobs. In this case, this one can only be 12 volts or 5 volts. Or some of them have more solder blobs. This one can be configured for all the different voltages and is set up for 12 volts. Try a different power supply. (12 volts). If your cable supports 5 amps by the E-marker chip in it, you will be able to draw 5 amps when they're set to 20 volts for a 100 watt output. On the voltages lower than 20 volts, they're usually limited to 3 amps. In that case, you might want to post-regulate it with something like this. This one's a boost converter, so you can get 24 volts out, and this will trigger 20 volts. 20 volts, 24 volts out. It's adjustable. That's a better way of getting higher currents. If you need 12 volts out at a higher current, then use an efficient buck converter, synchronous rectification type, and set it to 12 volts, and then you will be able to draw the full 100 watts as long as you're using a capable power supply cable. These PD triggers are useful for this type of power supply, set to 20 volts and using an appropriate cable. You now have a power supply that can deliver up to close to 20 volts, maybe around 19 or 18.5, and with current regulation, so you can use it for charging batteries or powering your projects. The very important thing you need to remember with these types of power supplies is the power input to it cannot be shared with anything else, and its negative cannot be grounded, because these work by switching or measuring the in the negative connection, so the whole input power supply must be floating. Otherwise, if you joined this to ground or used an oscilloscope on the same circuit, you'll find that you're applying the full input voltage to your load unintentionally, and that will lead to things getting damaged. These little things are available on AliExpress and similar places, and you can build those into your projects to power them by USB-C. Another idea is to use a power bank that supports USB-C as a uninterruptible power supply. So if your power bank has enough ports to allow charging and running at the same time, in this case it's got USB-A outputs and only one USB-C in and out. So this one can be configured to run up to 12 volts output. It won't go any higher than that, and I think it does 1.5 amps at 12 volts. The good thing about this is when you connect and disconnect the charger, this power bank needs to have a bit of a load connected, otherwise it won't maintain its output. So it's providing some load now with a small electronic load, and when we connect the charger it will charge, and if there's a power cut it will stop charging and it will remain running on batteries, and your load won't be disturbed. Not all power banks will do that. Some of them will reset their output. It will go off momentarily when the power is connected and disconnected from the charge input. But if you can find one that doesn't, then you can use that as an uninterruptible power supply for powering small loads like your ADSL modem. It's another one that's similar. This one has got USB-C in and out here and USB-C out only on there. So a similar thing can be done. A load onto that in a roundabout way. Just inventing this as I go. So we're going to use the PD trigger board to trigger what voltage we want. There we go, we've got a 12 volt output running, and then when we connect the input, it's now charging there at almost 70 watts and providing output. And if the charge went away, power cut, the load stays running and it stays running on battery. Very convenient. Another thing that's available that is similarly useful are pre-made cables that have the PD trigger parts built into them. So this one will request 12 volts from the power supply, and we can check that. Connect up. So you get 12 volts out of this. Here's another one, very similar, but this one requests 20 volts. So don't get them mixed up, they're useful. So this one supposedly gives you the full 5 amps at 20 volts out, and the other one that does 12 volts you can use for powering something like your ADSL modem, which if that runs on 12 volts and uses a standard barrel jack, and then you can power it off of a power bank or a UPS effect, or you can power it off of a GAN type power supply, so it'll be more efficient than the included power supply. Another device you can get, this is a combination USB tester and power supply, regulated power supply. It has the ability to test protocols. You can use it to check what protocols your power supply supports. So at the moment we're connected to the USB-A port, so it won't support PD, but it should support most of the others. You can see the QC on this particular power supply doesn't support 20 volts, but it supports all the other protocols except PD. Yeah, reset when you try to run it. So if we put it into PER mode, which is power supply, you can configure the input voltage so we can get it to run on 12 volt input, and then how to get to the next menu, there you go, and then you can configure voltage and current, and it works just like a regulated power supply on these output terminals. they've done half the work for you. It's just a bit tedious to set up the input voltage because I think you have to do that every time. Seems to have remembered. When you put it into USB mode, it becomes a USB measuring device, and you can use the USB-C in and the A out there and the C out there to do inline USB power measurements. This model here, FNB48, which is just a USB measuring device, it has a very fast response. So as I adjust the load, you can see the current going up and down, and the way the voltage swings up and down as well. If you're using it to do things like charge a phone, you can see what goes on when phones charge. It's doing 10 watts there. If we were using a different cable, it would go into the 9-volt mode. It's not as interesting as I thought it would be. Maybe it's computers that are more interesting. They have a lot of noise on them. Oh, it's probably because we've got that in there at the same time. That's probably not helping. Okay. Anyway, so this USB meter has a very fast response rate and fairly high resolution. Quite a lot of details. This power bank here, I believe, does not support QC. It's got a USB-C in and out port, but only for 45 watts, I think. Whereas that one will do 65 watts and that one will do 100 watts. So we put this in the USB mode and we can check what protocols this offers. And you must not have any load connected, any USB device connected when you are checking the protocols supported, because it will be outputting weird voltages when it goes into those other modes. Well, not weird voltages, but we're just outputting voltages your load might not expect. This is just USB. There's no charging protocol supported at all. But they do give you this alternate way to charge it through a PD trigger device. So that triggers 20 volts, and then you can apply that into here, and then you can connect a load onto the output of the power bank. So if we join this load onto the power bank's USB-C terminal, it only supports 5 volts and 20 volts out, and we'll see what happens when the power gets cut. So it's currently got 1.7 amps there, 30 watts going into it. If we turn the charger off, you can see that the load gets reset. So it's not suitable to use this one. Look at that. When you're not charging it, it supports all the output voltage modes. So it probably has limited DC to DC converters inside here, so it can't deal with independent charging and discharging at the same time. Yeah. So that's a bit disappointing. This one's not as versatile as the others. That's the Lenovo one. That's the Storm 2 Liquid. So hopefully that was useful information about the possibilities of using QC and PD USB power supplies to power other devices and your own projects. Just be careful and test everything before you finalize your design and before you blow anything up with it accidentally. One thing I forgot to mention, you can get USB-C cables that have built-in meters. This one here will show the power consumption in watts. It also tells you it's into PD mode. So that's 62 watts there. Same thing will happen when we join it up to this one. 36 watts. Useful for seeing what your computer's up to when it's charging as well as your phone or your project. 1.5 watts. This is quite filtered. I'm not sure which one's more accurate. I assume this would be more accurate. Useful cable to have so you can tell what's going on with your computer or phone or other device.